Software Engineering Radio, episode 132, Top 10 Architecture Mistakes with Eoin Woods. Today's show is brought to you by Audible. Please visit audiblepodcast.com/ser for your free audiobook download.
This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio brings you relevant and detailed discussions and interviews on software engineering topics every 10 days. Thanks to our audience and the partners listed on our website for support. Welcome everybody to Software Engineering Radio. This episode is a discussion with Eoin Woods, yes, that's how you pronounce the name, about software architecture mistakes and what you can learn from them. But before we get to the actual content, let me briefly introduce our sponsors. This episode is sponsored by Audible.com. It's the internet's leading provider of spoken audio entertainment. They have over 51,000 titles you can download and listen to on all your devices, like your iPod, whatever. Among them, a lot of science and technology stuff. They have novels. They also have a specifically interesting science fiction section. So, and as a podcast listener, I guess there's a chance that you like to consume information via listening. So I guess Audible is a good match for you guys, for you listeners. As an SE Radio listener, you can get one book for free if you subscribe. It's at www.audiblepodcast.com/ser. And if you subscribe there, you can cancel at any time. I know that because I actually did that 2 years ago. I subscribed to get the free book and then canceled, but a while later I came back and now I am actually a subscriber. One of the books I listened to recently is A Rendezvous with Rama by Arthur C. Clarke. It's a very nice science fiction novel where some scientists discover that some kind of asteroid is, approaching the Earth, and they're already getting into position to defend the Earth, and then they notice it's some kind of spaceship, and then they explore it. So it's a very nice Arthur C. Clarke novel. It's read, I don't know by whom it's read, but it's important that you check who reads stuff, because a good reader can make a big difference. And it was a good reader, just don't know the name. So if you want to try it out, go to audiblepodcast.com/ser and give it a try. Thanks to Audible for supporting this podcast. Okay, and now let's get on with the actual content, the discussion with Eoin Woods about software architecture mistakes. Once again, this is an episode we record at the JAU conference in Aarhus, Denmark in, September, October-ish 2008. And today we're talking about top 10 software architecture and architect mistakes. Our guest today is Eoin Woods.
Hello. Thank you. It's very nice to be here.
Absolutely. Thanks for being on the show. So before we start, obviously, why don't you introduce yourself to our audience?
My name's Eoin Woods. I'm a working software architect. I'm not a researcher or someone who kind of writes books and is training for a living. Been doing software architecture since the late 1990s, I'd guess. Started my career with Bull, working on their version of a product called Tuxedo, which some of you may know. Mm-hmm. Spent some time with Sybase, working on database systems, system management, also working as a consultant. I've worked for a startup, Intertrust Technologies, in California. And most recently, I've worked for UBS Investment Bank for nearly 3 years. And most recently, I now work for Barclays Global Investors in London as a software architect, specifically on one major program, Apex, which is our new portfolio management system.
And of course, although you say you are a working software architect, you don't just write books, you did also write a book.
I did, in fact, co-author a book with my colleague Nick Rosansky, who has also, in fact, just joined Barclays Global Investors. So you never know. Maybe there's another one lurking out there somewhere.
And we'll put the book URL into the show notes, of course.
And there's good free stuff on the site to download, so thanks.
Cool. Yep. So before we actually look at those top 10 things, obviously you call yourself an architect. So you you must have some understanding what it means to be an architect. So why don't you briefly express or explain the actual work you do? Because this is always an interesting question. I mean, what do architects do?
Indeed. It's a very good question. And I separate architects into 3 buckets, actually. There are people who do enterprise architecture, and I definitely don't do that. Mm-hmm. And I'd summarize them. They're the people who work out what systems need to be built and how they should be linked together. There's the infrastructure architects, and I definitely don't do that either. Those are the people who are experts in how the company should use a particular technology stack or kind of technology. So you might have, data architects who decide how your databases should be used and so on, middleware architects, who worry about messaging and app servers. And then this is the sort of architect I am, and we're the people who build systems, or rather we lead teams to build systems. We're a bit like team leaders, except that we don't tend to have people reporting to us. So we tend to have the ultimate responsibility for all the technical decisions made in the system development lifecycle. But of course, inevitably, because you're responsible for a lot of decisions, you're really responsible for other people's. So it's a question of making the biggest decisions yourself and then shepherding other people to make decisions you think are sound inside that kind of framework.
So how would you define architecture?
Oh, that's a very good question. Actually, my flippant response to that is it's the set of design decisions that if you get them wrong, they'll cancel your project. They're the ones you really have to get right. Another slightly flippant but maybe more useful definition is they tend to be the design decisions that people outside the project care about. And indirectly perhaps, but they can see them or they're affected by them.
The definition I like to use is all the stuff you want to be consistent all throughout the system for reasons of achieving non-functional requirements or reliability or maintainability.
And that's another great definition. Definitely the scope of the decision is one of those things that separates a design decision, one designer working in a subsystem, and an architectural decision, which is something that affects the whole system.
I think one definition that's often used talks about granularity and scale, and I think that's probably not useful because you might even have on a very fine-grained level certain architectural constraints, like for example the locking protocol to be used. That's very detailed about how you access a resource, but it's still architectural because it's cross-cutting and kind of global.
I completely agree.
Okay, then. So I guess your top 10 architecture mistakes are, I would guess, basically kind of lessons learned from working as an architect and seeing how people go wrong, right?
That's right. 10, of course, is a somewhat arbitrary, nice round number.
Of course, yes.
And I'm sure if I'd carried on thinking, perhaps I could have come up with a few more. The background is I'm a member of the International Association of Software Architects, ISA, isahome.org if you're after it. So they have a program where they find publications who are interested in articles being written and approach me and ask me for an idea. And I came up with this idea. And then I think somebody at JOO saw the idea and so invited me to give the talk based on it. So 10's perhaps a nice round number, but the way I came up with these specific problems is they're all ones I've seen, they're all mistakes I've seen made more than once. And they've tended to be painful.
Okay, so let's start with the first one. It's called scoping woes.
Yes, this is where there's obviously two problems with scope. One is you get it too narrow and one you get too broad. And you'll tend to get different people interested in the project, stakeholders, if you will, pulling in different directions on this. Is that it's very common to see, senior management will decide that a very, very minimalist system is exactly what they're after because they'd rather not pay for anything bigger because the budget is rather fixed. And then you'll get perhaps an end user or perhaps somebody else, maybe even a systems administrator, deciding that there's a whole lot of features that they'd like added, which really aren't required, but they can make a good case for them. And scope in either direction is a problem. And actually, functional scope's one thing. I need it to do this, or it shouldn't do this. But actually, the thing that often comes back to kill you is the non-functional scopes. So it's getting the scope of things like how much security you really need wrong. And you can end up in a morass of security protocols and people and technology that you didn't really need, or you can't go live because you missed out an important aspect.
It's probably some of those non-functional requirements for which it's not necessarily easy to explain the trade-offs. I mean, of course everybody wants security and scalability and everything, but all of those come with a cost.
That's absolutely true.
But that cost is sometimes hard to put into numbers, I guess, and that's where some of the problems come from.
Indeed. I mean, my classic example is that if you get the security scope too narrow, the hidden cost is you can't go live with the system, because somebody at the last minute will tell you it's too narrow. They won't come and find you and tell you it's too narrow. You've got to go out and find them and check that it's wide enough. And that's a very big cost if this system is business critical.
Have you seen that a system that is perceived to be really important for the company or organization going further, that it has been cancelled for reasons of security really right before it went live?
Never cancelled, but in the security software industry, there are many stories of big product releases being pulled at the last minute because somebody hasn't checked off a verification test, or somebody didn't realize that some extra protocol was required. It's not that you can the project, don't get me wrong, it's not that serious, but suddenly you've missed a release window, which actually, that might be the hidden cost. It's the fact that 3 months later the system is less, or the product release is less valuable.
So, of course, I mean, just highlighting problems and mistakes is one thing, and it's useful in itself. But maybe we have some remedies. What can we do? I mean, what do we do to hopefully get scoping better, right?
I knew you'd start asking hard questions at some point. Yes, I mean, scope is just tough to get right, but the key thing really is making sure that you understand who the decision makers and the important people are who have a say in scope and who will be affected by scope, and get them on board early. It's very related to the second point, is about talking to stakeholders, but the two are very closely related. But really the first one is what happens typically when you don't cast your stakeholder net widely.
And I guess the other thing that's related is then, if you have the stakeholders, that you make it clear to them what it means to either not have a certain thing in scope or putting something in scope and then talking about the cost of adding that, so actually, they can make a real good decision.
That's a very good point. Just informing the stakeholders often really doesn't achieve anything, because they'll simply nod. They really won't understand the trade-off that you're trying to get them to make. And you often have to bring, senior managers, the classic thing is you have to bring the trade-off on three PowerPoint slides, give them the options, get them to make a decision.
Exactly.
But even I've found, sometimes you deal with an enterprise security group, and really they won't really pick out the decision you're trying to get them to make. They'll really just give you further advice, which is not really what you're after.
Yeah, because they don't want to be responsible, maybe.
That's probably part of it.
Okay, so as you said, the next one, not talking to as many stakeholders as you should, is very related. So can you explain that and also distinguish that from the first one?
Sure. Well, as I say, I think it might be, now I think of it, it might be cause and effect, really. Or certainly one of the effects of not talking to enough stakeholders and taking them seriously and really listening to them is that you'll end up with scope problems. You may end up with other problems as well, of course. Yes, I mean, for most systems, the classic stakeholder is the end user and probably the acquirer, so the person paying the bill. So I'm talking about an in-house system here. The problem is that for many teams, that's where it starts and stops, and they don't really think any further than that. But if you think about the life cycle of a big system going into the enterprise environment, there's a lot of other people who care. I mean, classic people would include people who will have to support the system, who may be different to the development team, or might be the same, but they've got two hats. The infrastructure folks,
the operations
DBAs, people who'll operate it, absolutely. People like enterprise compliance, audit, control, all those people, especially if you're in a regulated industry, such as medical or finance, they have a lot of say. And so there's a whole lot of people who aren't, if you like, business users. I mean, they, in a sense, they don't necessarily contribute anything directly to use of the system, but get it wrong for them, and there's probably a lot of pain just down the road for you, because you'll have to force the changes in.
Another characteristic of some of those groups is probably also that they're not going to actively, come to you and tell you, here is what we need. They just sit there passively, and then if you don't conform to their expectations, you're hosed.
That's absolutely the case. The classic problem with dealing with an infrastructure group, and to be fair to them, they're very busy people, under-resourced and everything, but the problem is they do sit there passively, and then at the last minute, your system turns up, and then they'll complain about not being involved. Well, of course, you didn't realize they had to be. And that's just where experience, really, and organizational knowledge comes in. So these people need to be involved earlier. The other thing is to describe your architecture, your system, in a way that they understand. And that's with this idea of architectural views. You don't draw one big picture because no one will understand it. Draw pictures aimed at the different people who care.
Right. So I mean, obviously sometimes I get the impression with those groups that they, well, obviously they don't directly benefit from the introduction of a new system. It's more a chore for them to have to operate it. And that's how it seems. Of course,
that's perfectly true, yes.
Organization as a whole benefits, so they do. But that's maybe why they're kind of passively sitting there and not actively saying, I need this requirement, it solves my problem, because you don't solve their problem.
Perfectly true. I mean, I separate stakeholders into positive and negative.
Right,
Some want the system to be there and to succeed.
Very good point.
compliance, every new system is a risk. Why would they want it in production?
Right.
And so it's their job to block it.
Yeah.
It can be argued. And of course, many compliance people are very positive, to be fair, in
Sure.
getting
Not about
involved.
bashing.
But if you look at it from a pure self-interest point of view, why would they want your system in production?
Right. Exactly.
Yeah. And that's really the problem, is that get those people on side as early as you can, because they need to be your friend.
Another thing in this context is that I've experienced with, especially with large customers, is that they already have a bunch of existing frameworks, platforms, tools, libraries for logging, for example.
Yeah,
and if you don't use that, your system won't fit into their operations infrastructure, and then again you're screwed. So
that's
knowing their technical requirements is something that's very, very related here too.
Absolutely. And it's often painful for the development team. They don't want to use this library. Or I worked for UBS Investment Bank for nearly 3 years, and they have various system monitoring things that you have to do there for good reason, and that's why they have reliable systems. Every development team bitches about them, but they're there for a reason. If you don't standardize, it can't be supported. So you just have to live with it.
One customer I worked for had the same kind of thing, but they didn't document their frameworks, and they had no people that actually could come to your project and help you get things right. So you had to use it, but you basically couldn't.
Actually,
that was very bad.
I've tended to find that's the norm, really. You must do all this. Good luck. And who knows what's going to happen? And if you get it wrong, we'll tell you just before you go into production.
Right. Yes. Yeah. That's and then it becomes a power play of whether you get it running or not, depending on who is more important in the company.
Indeed, whether the business unit can swing their influence.
Exactly. Okay, next one, focusing on functions, or the other way, of course, is forgetting the non-functional stuff, right?
Indeed, yes. This is the classic problem where you ask somebody what you want the system to do, and they'll give you a laundry list of functions, as we've already mentioned, some that they really need and some that they just kind of like if you can do them. What they'll never tell you is all the implicit quality requirements. That it's got to be available during these hours. A failure costs them this much money a minute. There's this many users will be using it, and it must be able to process this many items in an overnight batch within a 1 hour window, while the database is still in use by another region. There's all these things about how the system's going to do it. And I yet have to meet any kind of end user, to be honest, who really can help me specify those very precisely. You really have to go out, assert some things are correct, find out if they're not, find potential clashes with the way the organization works and other systems, learn from other systems, especially if, like me, you're quite new to an organization, find out where others have had those problems. And then really go through a checklist of all the different qualities that you think might be relevant as to what are the top three, how do they, and the trickiest bit, how do they trade off against each other?
Yeah, exactly. That's the problem with the non-functionals. They always kind of balance between various of them, or several of them too. Another thing that I read recently, I don't remember where. Oh, it was in Tom DeMarco's new book, the Adrenaline Junkies, where he talks about straw man, where he says, and that goes back to our scoping thing also, where you have to really build a straw man scenario that says, we're going to build a system, but it requires a reboot every night, and we need 1 week per year to install the new version, and it's going to be over Christmas. Is this okay for you? And of course, it's a ridiculous statement.
I think that's a great idea.
It provokes the stakeholders to become, basically to protest and say, no, it needs to be this way.
Indeed. I have done similar things. You've got to be careful how often you do it, but I have done it to provoke a reaction. And also you find out if they've read the document.
Right.
Because if they don't come back with any complaints, you know they didn't read it, no matter what they say. I think that's a great idea. I must find that book.
It's a nice book. It's like a collection of 95 patterns or something that they detected in projects about behaviors that work and don't work. And
excellent.
We'll have an episode on SE Radio at some point with those guys.
Very good.
So with these non-functional qualities, the problem is often that you have to somehow make them concrete into numbers, like we need a reliability of such and such many nines or whatever. What's your experience? Can you make typical stakeholders actually commit to numbers, or are they afraid of being concrete so they can always say they wanted more than you did, or
I haven't really found them being afraid of being concrete. If anything, it's the opposite. If anything, if you make it concrete, they'll just simply sign it off, because it looks very precise and scientific, so everything's going to be fine. And it's only later they really think about what not having available on a Saturday morning means, and they don't necessarily think through the scenarios.
Right.
What you sometimes have to do is a little bit like at a much more formal level, sort of high process approach. The SEI's ATAM method for assessing software architectures is all very scenario based. Yeah. You can do a similar thing much less formally with a few sentences to kind of illustrate to somebody what a particular quality requirement is going to imply for them. So they can, I don't know, process 1,000 units per hour in the nightly batch. This means we can't process more than 2 regions overnight. And then they go, oh, no, hang on. And you say, well, you've only got 2 regions. And they go, no, but we're about to have 6. And you go, right, we've uncovered a quality requirement. Thank you. And some, though, are still difficult because things like security, you can do scenarios, but unless the person is a security specialist and used to things like threat modeling and thinking about security, it's quite tricky to get people to react one way or the other. And most of us, frankly, are not experts in security ourselves.
Yes.
So there are still qualities that it's tricky on. Evolution's another great one. I mean, the SEI have got this great example in one of their training manuals about stimulus to the system is change database from MySQL to Oracle. Requirement is must be able to do it in 20 man days. Well, I don't know about you. I don't know how long it would take to change the database on my system. And I'm not quite sure how I'd work it out without trying it, which would be a lot of work. So some of them are just hard. And to be honest, I think in some areas like evolution, they're really more aspirations than requirements you necessarily can honestly say you can meet because they're very hard to test.
It gives you at least topics to focus on, like your database thing example. You know that database independence is important, so you think about and you take precautions about making things from the database not show up in the APIs and stuff.
That's perfectly true. And it puts the fear of God in the right areas, so it can be useful. Yes. Yeah.
So the next one, bubbles don't crash, right? Using box and line descriptions. What's the problem with that?
Well, it's not so much that pictures are a bad thing. In fact, I'm a very pictorial thinker, and I find a lot of software designers are, as are designers in traditional industries too, traditional engineering industries too. The problem is the either A3 Visio diagram full of boxes and small arrows, all with slightly different dashes on the arrow stems and different shading in the boxes that everyone's forgotten what it means. Or equally well, the 5-box PowerPoint slide with a different type of border on every box and lots of arrows joining them, but you're not quite sure what the arrows mean. And sometimes those things have their place. When Nick Rosansky and I wrote our book, we referred to those as cartoons, as sort of informal informal architectural sketches. That's actually not how, for example, the SEI use the term cartoon. They use it differently. But I mean, our kind of idea was sort of having done all the formal stuff, if you need to explain it to somebody quickly, you'd sit down with a piece of paper and a pencil and you'd draw 5 boxes. That was our idea. You'd be sketching a cartoon. And that's useful. But if you don't have the actual description somewhere, you actually don't know what the components of the system are or how they fit together. And the snag is that if you do it all with some strange notation you don't bother defining, everyone thinks they understand it, and actually no one does.
So this I mean, you kind of hit a nerve with me because, as you maybe know, I'm modeling, doing a lot of stuff. And so first of all, I tend to prefer textual languages over graphical ones, but this is another discussion. So I distinguish between modeling and diagramming, and the diagram is kind of your cartoons, right? It's a visualization of something that doesn't need to be formally defined, but the notation must be clear. Not formally clear, but intuitively clear. And then on the other side, you have models which you can actually process, generate code from, and validate.
That's
something completely different.
Yeah, to be fair, absolutely. I in this presentation in particular, I neatly gloss over this. Which, in fact, if any of my engineers are listening to this, they'll be shouting at their iPods because I'm always telling people off for drawing pictures and not putting a model behind it. Yes, for me, the picture is simply a representation of the model. Which is why we try and use some tools like. Magic Draw is one particular one we use that has a real UML model behind it. It's not just a picture in Visio. To me, actually drawing the pictures is often not that valuable because you can't use the information for anything. If the stuff's in a model and you can navigate through the repository, you can ask it questions. Now, you may have to write scraps of code to ask the questions, but you can ask questions and you can get answers back. And it's tremendously more valuable.
So in this context, you say that using box and line descriptions is a mistake, is a problem.
It's a potential problem.
It's a potential problem if it is used in this non-formal way. So turning it around, do you think there is a benefit to describing architectures formally?
Well, I think that very much depends on the scale and the environment. With every deliverable, but especially architecture deliverables, the question to ask is who's going to use it.
Mm-hmm.
Providing you have a constituency, some people who care, that there is some formality behind your architecture and that they can animate it or generate something off it or just simply maybe run reports on it,
right,
then it's useful to have some level of formality, especially machine processable formality.
That's what I mean by formality. That's my definition of formality. I can write any tool that checks constraints on it or generates code or
right, because I came originally from a formal methods background.
See,
there was a tremendous amount of writing upside down A's on whiteboards and then not being able to process them.
Right. Yeah.
To be fair, even the formal methods community has moved a long way beyond that.
I tend to use the term processable as opposed to formal in my talks for exactly that reason.
That's something I'm always thinking to myself when I'm typing stuff into a UML tool, supposing I am doing that.
Yeah.
How could I pull this out later?
Yeah.
Would it be useful?
So you just said, suppose I do that. Do you actually use UML regularly, and do you use it for diagramming, for communicating ideas, or do you really use it in a formal way, formal being defined in the sense we just said?
I do use UML. I must say, as a percentage of my time, it's probably actually producing models and diagrams is quite a small amount of it.
Mm-hmm.
But yes, every architecture document I produce, I do use UML to describe my main structural views.
Mm-hmm.
The way I always describe UML is it really sucks as an architecture description language, but I haven't yet found a better one.
Well, yeah.
Especially one in general use that I can buy a tool for.
So that's the point, because this is more like my opinion, and I maybe should keep it out of this episode. But I think, and maybe just briefly, I think a big sweet spot is actually defining your own language for that captures your architectural abstractions of your system or product line or platform, whatever, because then you don't have to shoehorn your abstractions into an existing generic language, but rather you express things as a language. As they are defined in your environment. So that's the approach I take.
Yeah, actually, I think we're in sort of violent agreement.
Okay.
In fact, the one good thing about UML really is that you don't need to put up with a language as it's shipped. It's extensible.
In some sense,
and tools have just caught up with the extensibility of adding proper stereotypes and adding predefined attributes and so on. Yeah. Of course, you're stuck with a meta model, and you just have to deal with that. Yes, I'm actually very interested in whether some form of practical in fact, it would be textual DSL can be produced, and we can all work together to do a kind of Spring-like thing, something that sits on top of Spring components, something like that, where your architecture is actually part of the system. It's not a separate artifact.
Actually, this is exactly my point there. It's a kind of executable architecture. You
Absolutely.
go from just having verbal or pictorial input as an architect, you go to concrete, processable, usable artifacts that are part of the system.
Indeed. And today, of course, we do that by doing the first cut coding. We create the Java packages, we put the main classes in place, we put a lot of other empty classes in place, and we say to everyone, work in the framework.
Right.
And that's kind of our executable architecture. But of course, we lose 2/3 of the architectural information.
Yeah, sure, because you can't express it in code.
Absolutely.
So that's where you need, I think we need to talk after.
Yes, sounds like it. Yeah.
Because I have this approach currently in progress with a couple of customers.
Oh,
and it works really nice. But this is another thing. Okay, next one is forgetting that it needs to be built.
Right, well, this is the classic problem if you're using spending too much time in a UML tool and not enough time in an IDE. It's deciding that we're going to use this latest, sexiest bit of technology, which is just going to be fantastic and have all these benefits, forgetting the fact that the team who are going to build it with you are profoundly unenthusiastic about about what you've decided to pick up. I don't really want to learn it, and actually, your infrastructure guys don't think they can run it. I mean, these are all things which have happened to real systems I have shamefacedly been involved in. Is that, and it needn't even be a new bit of technology, it's just a new way of using it perhaps, is that you can only move as fast as your underlying platform and your sort of development constraints.
Right.
If you don't have the team that can build it, if you don't have the money, if you don't have the time, if you don't have the infrastructure environment, if you don't have the support guys, there's just no point in deciding you're going to do this new sexy thing. By all means, go and play with that on a Sunday afternoon, but on Monday morning back at work. You've got to have that reality check.
Yeah. So this is also a little bit the ivory tower architect problem, right? So you have an architect who only has on cloud 7 with concepts, as opposed to actually looking at the code and dealing with the real world developers.
Indeed. I mean, my pet bugbear at the moment is SOA, and the number of central architecture teams who don't have a delivery responsibility for systems, who have decided that you should build systems using SOA. Yeah. And I yet really have to find all that many what I would call stream architects, the guys actually building systems who are terribly enthusiastic about SOA. It seems to bring a lot of baggage with it. Yeah. And that it's a classic problem. If you're sitting centrally and you're looking at principles and concepts, it's very easy not to follow through mentally in the how would I actually build with it and run it in production. Yeah.
Yeah, this is another thing where I think concepts are important in architecture. So you think about things like decoupling and decentralization, compensation as opposed to locking. It's important, but as you say, you have to find a way to bring it down to the real guys who have to work with it and make it relevant for them.
Indeed, and make sure also that the problem I've observed in myself as much as others, I'm pointing the finger at myself here, is you download the new cool language, the classic at the moment being the functional language, right?
Yes, sure.
You download it, you play with it on your MacBook, which of course you can't connect to a corporate network because you use PCs. It's completely isolated, and you play through a whole lot of tutorials, and you go in suddenly very excited about the potential of functional languages. You haven't actually worked through a real problem that you might hit in the real deployment environment. Until you've done a bit more of that, you need to keep your enthusiasms under control, is my view, really.
Yeah. Okay, next one. Lack of platform precision.
Well, this was the problem I had very specifically when working for a company, I'm sure they won't mind me using their name, Intertrust Technologies, who still exist. They're now a subsidiary of Sony and Philips. They're based in California, and they do digital rights management systems.
Okay.
Boo hiss.
Still in business?
Still in business. Well, they're subsidiaries of very, very large companies.
Okay.
They're mainly famous not for their technology, but for suing Microsoft and winning, which most companies haven't. But they own a lot of patents in the area. A specific problem we had there actually was versions of the Oracle 8 C client, and the fact that I can't remember the exact numbers, but something like 8.0.17 was fundamentally incompatible with 8.7.15, and none of us quite realizing and thinking, well, it's 8.0, it's all Oracle, right? It should all just work. And actually, it caused all kinds of problems on the server and caused internal server disasters. I have observed this actually in quite a lot of places, and I started my career, as I mentioned, as a system software engineer, so working on a product called Tuxedo. And we always used to cuss at customers who used to report bugs that were quite obviously mismatched configurations. Of course, I didn't put the pieces together in my mind then. Actually, it's quite hard in the real world to put all the pieces together. And unfortunately, Java and .NET, to be fair, I think have massively simplified this. But even in those environments, you can't just assume it's going to work on the next JVM or on someone else's JVM without any problems. If you buy an Azul appliance, you're going to need to go and check that all of your funky locking code actually works the way you think it does, because you may be relying on a side effect that you're totally unaware of.
Yeah, this whole in concurrency, that kind of thing becomes especially problematic.
Indeed. And I've come across it a lot together also in database systems, especially interop between things like you've got a Sybase database and an Oracle database and you're replicating between them. It's all just meant to work, and then you need to upgrade one small part of one of the products, and suddenly all the dates appear with the wrong century or something. And it's because some engineer somewhere's reset a default that was maybe should always have been applied. It actually fixed a bug, but it's not going to help you.
Another thing that comes to mind in that context, and maybe it's related, is the trying to be platform independent to a degree that is kind of pointless. So, because adding 5 different indirection layers, of course, adds complexity and all that. So, trying to be too independent of whatever platform, persistence, middleware, probably is also an anti-pattern that you might want to be on the lookout for.
I think that's a fair point, actually, yes, is that you can build this tottering stack of abstractions. I have seen this system where people start with a pub sub bus, they sort of build a queuing abstraction on top and then realize they need multiple point delivery. They kind of rebuild a pub sub thing on top of the queuing. It just absolutely. It's like Dan Hayward, the independent consultant who was widely known for a bit for criticizing OMG's MDA. Dan always says, you've got to lock yourself into something, and I'd rather lock myself into Java than UML.
Right.
And, at some point you have to get concrete.
It is a fine line, though, because, of course you don't want to see, angle brackets from XML and specific database specific code in your applications. But on the other hand, trying to so that you want to abstract from that, but trying to abstract from, let's say, a communications paradigm.
Indeed, it's probably. I mean, the things to look out for are really, I think, the fundamental parts of your platform, whatever you define that in your environment. So, for example, for an embedded guy, I guess it's chipset. It's hard to completely ignore the fact you're running a particular chipset. Yeah. In my environment, it's much more about the fact that we use, for example, WebLogic Server.
Right.
And, sure, it's a standard thing, and in theory we could move it to JBoss tomorrow. But actually, we know that we've got heavy reliance on J2EE, and in fact there are situations where we make a decision that we're going to be quite reliant on the particular server that we're using.
So what I try to tell my customers is that they should stay away from making their application code dependent on a specific technology, but of course they should be relying on a paradigm. Like, for example, it's perfectly okay to assume PubSub or messaging, but it's not useful to necessarily code TIBCO APIs directly in your application. So there should be an abstraction of the technology, but not of the paradigm. So that's
that's a pretty good rule, I think, to be running with. The problem, of course, being the lowest common denominator abstraction problem.
Right. Exactly.
TIBCO, for example, I mean, TIBCO RV, if you're really going to use it in a high-performance system, it's quite hard to ignore all of TIBCO's APIs.
Right, and then there comes the next thing, which I then, if this reply comes, then what I typically add is that if you do technology-specific things, make sure you isolate it and you're aware, so that if you need to change something, you know where you need to touch things. So you don't have the technology, spread through like a cancer through all your system, but you have it isolated to certain, methods, framework parts or whatever.
Absolutely. I think, the key message is understand your dependencies,
that's
where you're
a very good point.
On.
Yes, that's...
And that's the meta point, but absolutely, it's if you're going to lock yourself into TIBCO RV, know where your contact points are and know what you rely on.
Right.
And that's the best advice you can give, I think.
Performance assumptions.
Yes, so this point, performance is really just a poster child here for making assumptions, particularly about non-functional requirements. Assuming that because your application server offers a clustering feature, that it's the clustering feature you require and that it works in the way that you need it to work.
Yeah.
Assuming that because a database vendor, my classic example would be assuming a database vendor has benchmarked something at a speed that you could get anywhere near it. I mean, which, having worked for a database vendor, I know most customers never did, and for good reasons, considering how much effort goes into a benchmark. I think the list goes on and on, really. It's that you can't possibly test everything, but some things are going to make a big difference to you if they turn out to be vastly different to what you're expecting. And so you need to, you need to be testing if you possibly can, building prototypes. If that's too expensive or difficult, you need to do things like performance models or security models. Really try and work through in your head. Is this credible that we could run this fast, or that this couldn't be broken, or that this honestly could move all the workload in flight between these machines? In many cases, you'll come up with a sudden light bulb will go on. You'll realize that's not going to happen for the following reasons.
So in some sense, it's also, you could rephrase that as don't believe marketing speak.
That possibly is the less vendor friendly version of it. Yes, indeed. Yeah. Don't assume that all the stuff in your environment works the way that people tell you.
Right. Yeah. And then of course what you do against that is that you do load tests with mockups early, right? In case of scalability, or really build spikes that verify certain behaviors of your platform, right?
Yeah. I mean, the best thing is hands-on testing, and and this is where I think if architects aren't on the critical path coding the application, they can stay hands-on and relevant and up to date, and B, perform a very valuable function for the project by building the performance prototype, integrating the security platform, and checking that the security team are happy with it. Actually checking that failover works the way they think it does.
So that's actually probably a recommendation on itself, which would be build a prototype that only verifies the non-functionals and fill the business logic with sleep statements, right?
Pretty well, exactly.
Yeah, that probably helps.
Yeah.
The next of your top 10 software architects' mistakes is do-it-yourself security.
That's right. It's really do-it-yourself infrastructure, but security is the best example that seems to keep cropping up. It's the fact that pretty well every software engineer, if you ask them in a quiet moment, will feel that they can probably whip together good infrastructure, such as a cryptography algorithm. And it's not till you work with real experts and you realise that there's a bit more to it that it dawns on you that actually you probably can't. There is a reason that security products, for example, tend to cost money and tend to be quite complicated because the problems they're solving are complicated. And there's a real danger if you do blunder forwards with a little bit of knowledge, just enough to be dangerous, then you're likely to cause problems later, ones that may only come out in production, because it's when the system's actually in use you find that perhaps it doesn't scale the way you thought it did, or you've tried to write your own cluster and it really doesn't have the failover characteristics you need.
And in security, I think it's especially true that because writing the algorithm, of course, is only half the story. You have to use the algorithm in a system that is secure as a system. Otherwise, you introduce all kinds of backdoors and stuff. That
Absolutely. There's a whole lot of moving parts, and they need to be integrated. Otherwise, you have security holes right through the process. So.
Another thing I think related here is, in addition to not doing it yourself, is also there are some concerns, security certainly is one, that you cannot easily retrofit afterwards, that you have to think of and plan for right from the beginning.
Absolutely right. And of course, there's the flip side. You don't really want to lock yourself into a particular security product, so you need to get the right abstractions in your system. But yes, I mean, all of these qualities are hard to retrofit afterwards. So making good choices about what abstractions you need in your system, and then using proven reusable infrastructure makes a lot of sense in most cases. There are always the Googles, and they're a little bit different. For them, it makes sense to build their own because they need a different set. But for most of us, using the stuff off the shelf is a good first step.
I agree. Okay, the next one is that actually reminds me of the interview here. It's called No Disaster Recovery Plan, and the reason why it reminds me of the interview is actually that this is the second part. During the first part of the interview, the recorder died, and so anyway, no disaster recovery plan.
Indeed, you can never. Well, that's the lesson. You can never predict what's going to fail.
And something's always going to fail.
That's right. And most of the systems that we work on, businesses or organizations are pretty dependent on them. It's quite rare today to find a system of any size that you can remove it from the organization and the organization continues at anything like the efficiency, profitability, and in some cases the organization simply has to stop that business until the system's repaired. The problem, of course, with disaster recovery, it's a bit like paying for your house insurance. Nobody really wants to do it, and especially up front, early in the project, when you've got everything to think about, it's very tempting to push disaster recovery off because it's not actually needed until you're in production. The big difficulty with that is that my experience is that actually if you introduce disaster recovery incrementally as you build the system, as you design it, it's not a great overhead. For every piece you add, you have to work out how you're going to do recovery or failover on that piece. Adding it afterwards to a system that's had no thought of disaster recovery from the beginning, that goes back to what you were saying. These things are hard to retrofit. And it's very easy to end up with a system that actually can't be efficiently fell to a disaster recovery site. And you end up with all of these manual steps that have to be done, which are just asking for trouble in a real disaster.
So this is probably a good point to remember, you guys, listeners, that we've had the episode on fault tolerance patterns with Bob Hanmer. I guess you know them.
Yes, absolutely.
And I guess this episode ties in here nicely. Look at that stuff.
Go away and look at them again. And also look at there's a very good book who I'd have to send you the details, but on high availability patterns and systems. That's again great resource. There's also there's a good book on clusters, which a lot of this stuff is really aimed at people building the HA infrastructure, but to have a deeper understanding of the patterns really helps you when you come to make your own stuff highly available, because you know what to avoid.
So this would be useful to get this link, and we'll put it into the show notes.
Sure.
Okay. And the last of the 10 is to have no plan to back out, no back out plan. What do you mean by that? I'm not.
Well, that's when you've decided that you're going to do the migration. You've planned it carefully. You start to do the migration.
Oh, you mean from the old system to the new one you built? To the new system,
indeed. And at some point in that process, you realize with horror, you're not going to get this done by, say, Monday morning when they're expecting to use the system. Or something simply breaks. In my experience, actually, to be fair, it's often not the application. It's that something has changed in the infrastructure environment that nobody was aware would affect this system. And suddenly, for example, the clustering isn't working, or they can't hook up to the security system, or there's a horrible delay as they try and get clients connected, and they just have to go back to the previous state. The problem is, of course, if you haven't got that previous state ready to roll back in quickly, it's very difficult.
Yes.
And I mean, in the worst cases, you have to allow for a window of 50% of your upgrade time to do a potential rollback, which is very inefficient. There's lots of shortcuts. You dump your databases first. You make sure that if possible, you have 2 sets of hardware, which is kind of expensive, but maybe you can share them with another project. You deploy onto one, and then you cut across. There's lots of relatively simple techniques, actually, but in many, many cases, people actually don't think out how to roll back as opposed to just move forwards during a migration. And they can simply leave their business without a system. And there's very few businesses are going to be happy with that on their Monday morning.
It was one of my first experiences as a programmer in a hospital. I spent the weekend going back from Microsoft SQL Server 6.5 to 6, although the stupid migration tool told me that migrating from 6.0 to 6.5 is no problem, everything's fine. So I pressed the button, and of course it failed.
Indeed. That's the problem with wizards. They're not as smart as they think they are.
That's a pain. Okay, so I guess that brings us to the end of your top 10. Is there any 11th that kind of comes to your mind that you wish to have added to the top 10 that you now think of,
Not yet, but if listeners have some suggestions, then they should send them to me, because I'm sure there's another 10 to be written.
Okay, yeah, cool. So, so anything else you want to leave our listeners with? Any words of wisdom?
I think they've probably had enough words from me. It's worth, though, saying that Software Engineering Radio, it's a great resource. Thank you very much for doing it. And I guess, listeners, if you've not paid your subscription, now's the moment.
Yeah, that's actually a very good point. Actually, I spent some of the money of the donations we got today to buy a new compact flash drive, because the original one failed, as I said in the first recording of this interview, but now somehow the second one has a problem, and I have to go back to the
So now we have a DR plan, and it's money wisely invested.
Absolutely. Thanks for being on the show.
Thank you very much.
Thanks for downloading and listening to Software Engineering Radio. Software Engineering Radio is an educational program brought to you by Hillside Europe. If you want more information about the podcast and all the other episodes, visit our website at se-radio.net. If you want to support us, you can donate to the SE Radio team via the website, or you can advertise for SE Radio, for example by clicking on the Dig, Reddit, Delicious and Slashdot buttons. To contact the team, please send email to team@se-radio.net, or if it is specific to an episode, please use the comments facility on the website so other people can react to your comments. This episode of SE Radio, as well as all other episodes, are licensed under a Creative Commons 2.5 license. Please see the website for details. Thanks to Charlie Crow and the Podsafe Music Network for the music used in this show. The song is called Vegas Hard Rock Shuffle.